Welcome to this explainer. We spend roughly a third of our entire lives doing it. Yet so many of us treat sleep like some kind of luxury we can just afford to skip. Like it's this passive state of doing absolutely nothing. But, well, science tells a totally different story. Sleep isn't just a timeout for your brain. It is an incredibly active, absolutely critical biological imperative. So today, we're going to explore the fascinating and honestly sometimes terrifying science of what happens when we don't get enough shut-eye. We're going to look at exactly how our bodies and brains react when we really push the limits of staying awake, and we'll uncover the hidden cellular mechanisms that make sleep the ultimate lifesaver. Let's get into it. Okay, let's just dive right in, and we're going to start with this unbelievable historical case from back in 1965. Meet a 17-year-old high school student named Randy Gardner. Randy decided he wanted to see exactly how his body would cope with zero sleep, and he managed to stay awake for a staggering 264 hours. That is 11 solid days, literally no sleep. Obviously, it's a super extreme experiment, but it provides this perfect accelerated window into the immense physical and mental toll that sleep deprivation takes on a human being. What's truly terrifying about Randy's experience is just how fast his cognitive functions began to unravel. Actually, scratch that. It wasn't a gradual decline at all. It was immediate. By just the second day, his eyes literally stopped focusing. Then his brain just lost the ability to identify objects simply by touch. A basic sensory function, totally gone. By day 3, Gardner was incredibly moody and uncoordinated. And by the time he hit the end of the experiment on day 11, the symptoms were just severe. He couldn't concentrate, had profound trouble with his short-term memory, became deeply paranoid, and even started hallucinating. Now, Gardner was young, and he remarkably recovered without long-term psychological or physical damage, but his rapid cognitive decline really establishes the immediate, severe stakes of sleep deprivation. Your brain essentially starts to malfunction and misfire almost right out of the gate. All right, moving to our next section, a widespread health epidemic and the reality of sleep loss in the U.S. So while Randy Gardner is obviously an extreme outlier, for the rest of us, losing shut-eye is just a chronic, everyday reality. We all know sleep is essential, right? Science tells us adults need a solid 7 to 8 hours of sleep a night just to function properly, and adolescents need about 10. But look at the reality here in the United States. An estimated 30% of adults and a whopping 66% of adolescents are regularly sleep deprived. To put that into perspective, that means a massive, massive portion of our population is consistently failing to meet their basic, fundamental biological sleep requirements. And let's be really clear about what this means. This is not just about feeling a little groggy during your morning commute. This widespread deprivation is a recipe for serious bodily harm. When we lose sleep, our foundational cognitive abilities, stuff like learning, memory, mood, reaction time, they are heavily compromised. But it goes so much deeper than just the brain. Chronic sleeplessness triggers severe physiological responses too. It causes systemic inflammation in the body, it spikes your blood pressure, and it's even been directly linked to a higher risk of developing diabetes and obesity. When you deny your body sleep, you're essentially opening the floodgates to a whole cascade of hormonal and physical illnesses. And unfortunately, chronic health issues aren't even the ceiling here. We have to talk about what happens when sleep loss crosses the line from chronic illness to fatal extremes. Which brings us to the lethal consequences. This is when sleep loss turns deadly. Back in 2014, there was this shocking tragedy that really highlighted the ultimate cost of staying awake. A totally devoted soccer fan wanted to watch the World Cup, and to pull it off, he forced himself to stay awake for 48 hours straight, just 2 days. At the end of those 48 hours, he suffered a stroke and passed away. His untimely death was a direct consequence of pushing his body's cardiovascular and neurological systems far, far beyond their waking limits. And that tragic incident wasn't just some freak fluke. The studies completely back up the fatal strain that sleep loss puts on the heart and brain. In fact, research shows that chronically sleeping fewer than 6 hours a night increases your stroke risk by 4.5 times compared to someone getting a consistent 7 to 8 hours. Just think about that for a second. Simply shaving an hour or two off your nightly rest massively multiplies your risk of a fatal cardiovascular event. And, if you need definitive proof that sleep is literally required for human survival, we just have to look at a devastating condition known as fatal familial insomnia. For a handful of people on the planet who carry this super rare inherited genetic mutation, sleeplessness becomes a permanent, daily reality. The condition places the body in this nightmarish state of continuous wakefulness. It literally forbids the brain from entering the sanctuary of sleep. And over the course of months or sometimes years, this progressively worsening condition leads to severe dementia and, inevitably, death. It proves without a shadow of a doubt that without sleep, the human body just cannot survive. So, seeing all this, from the hallucinations of an 11-day experiment to the fatal reality of a genetic mutation, we're left with a pretty huge pivotal question. How? How can the simple act of keeping your eyes open and staying awake cause such immense physiological and neurological suffering?
That takes us to brain waste and sleep pressure. Let's dig into the cellular mechanics. To really understand this, we have to look closely at ourselves. Let's break down exactly what happens during your waking hours. As you go about your day, your brain cells are incredibly busy, using up energy sources to help you think, move, and just live. But much like a car engine burning fuel, this process creates exhaust. The energy gets broken down into various chemical byproducts. Now, one of the most important of these byproducts is a chemical called adenosine. As the day wears on, adenosine steadily builds up in your brain. And as it builds up, it dramatically increases your urge to sleep. Scientists refer to this exact mechanism as sleep pressure. The longer you're awake, the heavier that pressure gets.
Which actually brings us to a super fascinating, highly relatable fact. When you drink that morning cup of coffee, caffeine doesn't magically create new energy out of nowhere. Instead, caffeine works by sneaking in and blocking the brain's adenosine receptor pathways. It essentially puts up a wall so your brain temporarily just can't feel the sleep pressure that's been building up. But make no mistake, that adenosine waste is still sitting there, waiting for you. So the crucial point is this: adenosine is not the only byproduct. Other waste products are also building up in the brain all day long. And if you don't sleep, these waste products are never cleared away. They collectively overload the brain's delicate ecosystem. Scientists now believe that this toxic buildup of unmanaged cellular waste is the primary culprit leading to all those negative mental and physical symptoms of sleep deprivation we just talked about, from the memory loss and paranoia to systemic inflammation and stroke. So if staying awake fills our brains with toxic byproducts, what exactly is happening when we close our eyes to save us from this cellular overload? That leads right into our final section, the brain's nightly cleanup, and how we restore the mind. Scientists have discovered this absolutely fascinating biological defense system inside our heads called the glymphatic system. You can basically think of it as a highly specialized cleanup crew. And what's incredible is that this system becomes much more active when we are asleep. When you drift off, the glymphatic system kicks into high gear, literally using cerebral spinal fluid to wash through the brain and flush away all those toxic byproducts that have been accumulating between your cells all day long. It is quite literally running an internal wash cycle on your brain. And it is a wonderfully complex interplay of mechanisms. As the glymphatic system flushes out the waste, recently discovered lymphatic vessels in the brain, which serve as pathways for immune cells, they also play a critical role in clearing out that daily garbage. All of this happens as we grow sleepy, prompted by signals from our body and our environment. Sleep-inducing chemicals like adenosine and melatonin rise, sending us into a doze. Our breathing slows down, our heart rate drops, our muscles relax, and we enter what is called non-REM sleep. This deep, non-REM sleep is exactly when this vital brain flushing occurs. And beyond the brain, this is also when our DNA is physically repaired and when our entire body replenishes itself for the challenges of the next day. As scientists continue to explore and map out these incredible restorative mechanisms, one thing just becomes absolutely undeniable. Sleep is not a luxury, it's not a corner you can cut or something to be hacked, minimized, or avoided. As the research shows, slipping into slumber is a biological necessity if we want to maintain our physical health and our mental sanity. So tonight, when you feel that sleep pressure building up, remember the incredible cleanup crew waiting to go to work in your brain and give them the time they need to keep you alive and well. Honestly, after seeing what happens when we deny our own biology, it really begs the question, in a society that constantly trades sleep for productivity, are we slowly keeping ourselves awake to death? Thanks for joining me on this explainer, and I'll see you next time.